This is CPM Precalculus Chapter 3, number 73. So here we're asked to look at the math note titled Definition of Logarithm. Why is b restricted to positive values? Okay, so let's take a look at the math note. Here we have the definition of a logarithm, and we have an example. The following two statements are equivalent, so that means they mean the same thing. Statement 1 means the same thing as Statement 2. Statement 1 says the exponent used to raise base 5 to 125 is 3. So to raise base 5 to the 3 power equals 125, right? The exponent used to raise base 5 to 125 is 3. Okay? Statement 2 says the log base 5 of 125 is 3. So we write either log base 5 of 125 equals 3, or without the parentheses here. The parentheses here are optional. Log base 5 of 125 is 3. Okay? And again, the way it's read is log base 5 of 125 is 3. So the definition then, written out, is we can use the previous ideas to give a definition of logarithm purely in terms of mathematical symbols. If b is greater than 0, so here's what the question is going to. If b is greater than 0, then log base b of x equals y means x is equal to b to the y. Okay, this is a definition that must be memorized. Okay, there's no intuition about it. You just kind of have to memorize it and use it. Okay, so what that's saying is if b is greater than 0, then y is equal to log base b of x. And that's the same thing as what power can we raise b to equal to x. Okay, so that's saying what power can we raise b to, and that's equal to y. So b, if we raise b to the y power, equals to x. Okay, and that's what we see here. So let's go ahead and say, why does b have to be greater than 0? That's the whole question. So let's go ahead and take, I guess, an example. Let's look at an example quickly. Let's say, well, let's go ahead and say, well, let's say it's a negative 2. So that's, we're saying b is not less than, it's not greater than 0, but it's less than 0. It's negative. Log base negative 2 of 8. Okay. How are we going to figure this out? Well, we know that's the same thing as writing negative 2 to what power? I'm going to keep, let's not write a question mark, but let's go ahead and call that y. Okay. So that's equal to y. So negative 2 raised to what power, which is y, is equal to 8. And when we have a negative number here, do we have any value of y for which this is true? So since this is negative, we don't have any value for y. Let's even be more specific. We don't have any real, okay, because we're talking about the real coordinate system, the Cartesian coordinate system, so we don't have any real value for y to make this true. Okay, and that's because there's no power to raise a negative number to get it to be positive. Okay, well, to get it to be positive 8, let's say. All right, another way to think about it, so this is just an example, and then we can go ahead and use this example to explain why. Or just, let's look at the definition of log. Well, if we know, let's go here and start here. Y equals to log base b of x. This is equivalent to log base anything, so let's just say log of x divided by log of b. Okay, because you can change, right now it's base b, you can change it to base 10 here by just dividing what we're taking the log of divided by the log of the same base of what you had as a base before, right? And what is so special about this? Well, we know that log of, log of anything that anything has to be greater than or equal to 0. Okay, actually has to be greater than 0, excuse me. Okay, so if we have log of, I don't know, log of x equals to, I don't know, y here, okay? Well, we know that inside this x, right, has to be greater than 0. And we could even test that out, right? Let's go ahead and turn this on. What is log of 0? Domain error quit, okay? So let's go ahead and quit. What is log? Oh, I did it again. Same thing. Let's go ahead and do log of -1. Log of -1. Again, we're going to have an imaginary number. Okay, so your calculator might not do this. I'm going to turn my imaginary numbers off. So I'm going to go into mode and go down to here to look at the real coordinate system only. And let's do it again. Log of -1. Now it's giving me non-real answer. Okay, just like we talked about, there's no real answer. Okay, so even if we graph, let's go ahead and graph log of x. Let's graph y is equal to log x. We graph this, right? The domain starts, so y is equal to log of x. The domain we know is when we start at 0 and everything to the right. Okay, this means we start at 0, everything to the right, excluding 0, right? Because we already know that log of 0 is an error, undefined. Okay, so this is the domain, and we know that this has to be true, right? So log base 10 of b cannot be anything less than or equal to 0, so b has to be greater than 0. Okay, so this shows us b has to be greater than 0. So this would be a mathematical way to explain it. You could also talk about the domain, right? Domain of log. And we could see that, well, the domain has to be greater than 0 as well. Okay, or you can go ahead and talk about an example of using a negative base. There is possibility to use a negative base though, so let's look at example 2. Log base -2 of -8 equals to y. Well, -2 to what power equals to -8? We know that -2 times -2 times -2 is equal to -8, so y here can equal to 3. Yes, but we know that here, if we have a negative base here equal to a positive number, there's no exponent in our real world that exists. Okay, so go ahead and take a note of the math note here of the definition of logarithm and memorize this. B has to be greater than 0. Y is equal to log base b of x means the same thing as x equals to b to the power of y. Alright, so that's going to end for us CPM Precalculus Chapter 3, number 73.